If a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by the equation h of t equals negative 16t squared plus 128t. Find and graph the x-intercepts of the function. Okay, so obviously we first need to graph it. Y equals negative 16t squared plus 128t. It's right there, it's given. Negative 16t squared plus 128t. Then we graph it, and I see it cross the x-axis how many times? Twice. Look, once right here at 0, and over here at where? 8. Okay? So it has two x-intercepts. One of them is 0 and one of them is 8. So on your graph, you can go ahead and plot them at 0 and then 8. Now, what do those numbers represent? 0 what and 8 what? Seconds. Okay? So wouldn't it make sense that at 0 seconds, it's 0 feet off the ground? And then at 8 seconds is when it returns and hits the ground? Okay? How can we find out how high this parabola goes? Like how high the toy rocket will get? You could do that, or there's another option. What? Well, that's kind of the same as the window. What did you say? The table. Watch what happens if I go to the table for this graph. I see 0, 0, which is before you have launched the toy rocket, it's 0 feet from the ground because we haven't done anything. And then I see that 8 seconds later, it has hit the ground. So in between those are all the heights. Like at 1 second, it reaches 112 feet. At 2 seconds, it reaches 192. So how high is it going to get? At how many seconds does it take to get there? 4. So all we know, we can't fit it on the graph because obviously we can't go up 256. But we know over at 4 seconds is going to be where it's the highest. So pretty much from there, we can just kind of, oops, hold on. A break in the graph. What I suggest is just kind of like what you see on the calculator. Just kind of, well, not behind it. Draw up, and then just kind of like leave a big gap showing that it keeps going higher, and then it comes back down. Now, when I get to here, should I stop at the intercept, or should I continue going and draw an arrow? Why should I stop? Right, you hit the ground, so you wouldn't go below ground. So that's where it would stop. Okay, so how long will it take for the rocket to return to the ground? 8 seconds. Okay, now turn to page 26. John is tossing a ball in the air. Because he's in geometry, he knows the height of the ball is represented by y equals negative 12x squared plus 50x, where y is in feet. So above the y, I'm just going to go and write ft for feet. And then x is in seconds. So above these x's, I'm going to write sec for seconds. When does the ball hit the ground? So they want to know how long will it take before the ball he tossed hits the ground. So what does that mean? Well, don't we know that when the ball hits the ground, the ball will be 0 feet from the ground? So couldn't we plug in 0 for feet because we're wanting to know when the ball is 0 feet from the ground? And now couldn't we just graph this? Okay, so let's graph it. Y equals negative 12x squared okay, we see two x-intercepts, one at 0 and one at a little past 4. Okay, the one at 0 is before he's tossed it. When 0 seconds have passed, the ball is still on the ground. That's what this one represents. But then the ball goes up in the air, and then at 4 point something seconds, it returns to the ground. How can you figure out exactly how long it takes? The problem with the table is that most of your calculators are set to whole numbers, and so we can't really do it that way. So what's another method that we know where we can get the exact value for x? What? Quadratic formula. Look, remember, this is in the form ax squared plus bx plus c. A is always sitting beside the squared term, b is always sitting beside the linear term, and c is the number that doesn't have a variable at all. So over here, what's your a value? What's your b value? 50, and what's your c value? Right, there is no zero. There is no c, so it's 0. So now first we find the discriminant. What do I mean when I say find the discriminant? Right, that's the formula for discriminant. So the b is 50, the a is negative 12, and the c is 0. When you type that in, what do you get for your discriminant? You won't get 0. You get something minus 0 because all of that becomes 0, but this is something. Right. So now we continue with the quadratic formula. X equals all divided by negative 24 though. Okay, because it's 2 times your a value, and your a value is negative 12. Now you just type each one of them in. So go ahead and do that. Type in negative 50 plus the square root of 2500 over negative 24, and type in negative 50 minus the square root of 2500 over negative 24. We already know that one of them is going to end up being what? 0, because we saw it on the graph that one of them was exactly 0. But the other one we couldn't see because it was a decimal, so type them in and see what it is. 4.2. So that means it will take 4.2 seconds for the ball to return to the ground. No, number 2 is a totally different question. All right, number 2. Jack throws a ball up in the air to see how high he can get it to go. The equation that represents the height of the ball is y equals negative 2x squared plus 20x, where y is in feet and the x's represent seconds. When will the ball hit the ground? So what does that mean? When will the ball be 0 feet from the ground? So we'll replace y with 0. And now the first thing you do is graph it, because if you graph it and it crosses at nice whole numbers on the x-axis, you don't have to deal with quadratic formula. So negative 2x squared plus 20x. Okay, we see it cross how many times? Twice. This one's definitely at, and this one is at 10. Let's check the table just to make sure. 0, 0, and then if we go down to 10 on the x-axis, we will see 10, 0. So it crosses exactly at 0, which is before it was ever thrown in the air, and then it crosses again at 10. So it took 10 seconds to return to the ground. Or to his hand. No, the ground. What? Yep. Okay, now I want you to take a few minutes and try all of page 27 by yourself. Okay, page 27. At a swim meet, Janet dives from a diving board that is 48 feet high. Her position above the water is represented by the equation y equals negative 16x squared plus 24x plus 40, where x represents time in seconds and y represents height in feet. When will Janet hit the water? So when will Janet be 0 feet from the water? So now we just graph it. Y equals negative 16x squared plus 24x plus 40. And we see an intersection with the x-axis at negative 1 and then right in between 2 and 3. Did anybody do the quadratic formula to find out exactly that location? Okay, you got the fraction 3 over 2, right? Okay, well watch. If you have the fraction 3 over 2, hold on. I'm trying to teach Cole. Are you sure it was 3 over 2 or 5 over 2? 5 over 2. Okay, to change this to a decimal, there's two options. Here's your two options to change it to a decimal. When the fraction is already sitting on your screen, you go to Math and number 2, decimal, and then you hit Enter. Or if you can't remember that, you can simply just type in 5 divided by 2, Enter. Okay, so you should get -1 and 2.5. Now, in the context of this problem, which answer really makes no sense? This one. You're not jumping backwards off the diving board, are you? Okay, so it means it will take her 2.5 seconds to hit the water. Oh, they're now giving us checks?
Yeah, you're rich.
Okay, number 4. Wait. Abigail tosses a coin off a bridge into the stream below. The distance in feet the coin is above the water is modeled by the equation y equals -16x squared plus 96x plus 112. So the first thing you need to do is graph it. Y equals -16x squared plus 96x plus 112. Okay, the x-intercepts are -1 and +1, 2, 3, 4, 5, 6, 7. So -1 and then +7. Which one of those doesn't really make sense with this, right? Because she's throwing a coin off of a bridge. So here's the top of the bridge. She throws it off. She's not throwing it backwards onto the road, right? Now, does anybody know how to tell me how high her coin will go? Second table. And then we can see that if we go back to -1, which is, the one that doesn't really make sense, and then here's 7, 0, the highest it got is how many feet? 256. Okay? So, basically you could just sketch your parabola as best as you could. It goes really high and then comes down. Should I continue my line below? Why not? It's going into a stream. Won't it go below the water some? Yes. Wait. So how long will it take for the coin to hit the water? 7 seconds. Okay.